Just like we can consider power for translational motion, we can consider power for rotational motion. The power is still equal to dw dt, which is the rate of change of our work with respect to time, or the rate at which we can do work. And we can now substitute in for rotational motion what that work is. For constant torque, remember we said that my work was equal to tau theta, torque times angular displacement. So we can say power is equal to ddt of torque times theta. If torque's a constant, then it can come out front and we get torque times d theta dt. Remember, the way we were able to say that omega was equal to tau theta relied on assuming that tau was a constant, so it's fine to pull it out like this. We haven't made any new assumption here. And that leaves us with our power for rotational motion with constant torque of that torque times the angular velocity omega. Let's try and work a simple example using this involving a boat engine. We have a boat engine operating at 9 times 10 to the 4th watts, running at 300 revolutions per minute. We want to know, what's the torque on the propeller shaft? Fair enough. Let's see if we can find that. Power is equal to torque times angular velocity. I want to solve for torque, so I'll divide both sides by omega, and I can say that my torque is equal to power over omega. Let's plug in numbers. Power is that 9 times 10 to the 4th watts number, and omega is 300 revolutions per minute. As we've seen, we're generally going to want to convert this to radians per second so that we don't end up with like watts per revolution per minute. That's a weird unit to put torque in. It's easier to put torque in something like Newton meters. We'll convert the revolutions using 2 pi radians is 1 revolution, and 60 seconds is 1 minute. That gets rid of the revolutions and the minutes, leaving us with radians per second. Now we have watts divided by inverse seconds, leaving us with joules per second times seconds, or just joules, which is Newton meters. You can write all that out to convince yourself that this is actually fine and I'm not pulling a fast one on you. And we end up with our torque is 2,865 Newton meters worth of torque for this engine.